Rank these molecules by the number of valence electrons they have. 1, 2, 3, 1, 3, 2, 2, 3, 1, or is there not enough information? First, we have to address the element in the room. All three of our molecules are presented in different forms. This is a Lewis structure, this is a chemical formula, that's a skeleton diagram. But does that prevent us from being able to compare the valence electrons for each? No, absolutely not. We can convert from one form into another. But given that we currently have one of each of these molecule forms, how do we decide if we're going to turn them into Lewis structures or bond line diagrams, etc.? Well, the great news is that we can directly count the number of valence electrons when we are in two of the three forms, either through counting sticks and dots or through multiplying and adding. So we have two of our three molecules in forms we can readily find the valence electrons for. But what about our bond line diagram? Well, very simply, we're going to have to convert our bond line diagram to either one of these forms. And it's your call whether it's to a Lewis structure or to a chemical formula. My recommendation is to convert it into a Lewis structure because a bond line diagram is simply a summary model of a Lewis structure. And if you look closely up at this molecule up here, the ends and the bends are carbons, and they may or may not have hydrogens directly attached to it. Likewise, the ends and bends of this molecule are carbons, so there are 5 carbons total. 1, 2, 3, 4, 5. And by nature of how carbon is structured, it will always form 4 bonds. 4 sticks with other atoms. But when we look at this, it's clear that most of these carbons don't appear to have 4 bonds. And that's simply because a bond line diagram hides a bunch of the features that would otherwise be present for the same molecule's Lewis structure. So each of our carbons does have 4 bonds, it's just that we don't see all of them. We only see the bonds between carbon and carbon as well as between carbon and oxygen. For example, we only see one of the 4 bonds for this highlighted carbon. But it still has 4 bonds total because hydrogens are going to make up the difference. It has 3 hydrogens single bonded to it because 4 minus 1 is 3. In fact, we use this equation for every carbon, and 2 of these carbons have no hydrogens because they already have their 4 bonds accounted for. 4 minus 4 equals 0 hydrogens for each. Now, we're not done. This is not the complete Lewis structure because the oxygens in this molecule have lone pairs that we haven't yet revealed. But here's the thing. We actually don't need to finish this Lewis structure. Remember, we just have to find either the Lewis structure or chemical formula from our bond line diagram to calculate the number of valence electrons. And to this point, we've already revealed all the elements and relative number of each. We've got 5 carbons, 2 oxygens, and 8 hydrogens. In other words, our chemical formula for this molecule is C5H8O2. And as I said, that's enough information to find the number of valence electrons. And now each of our molecules are in forms for which we are ready to find the valence electrons, and then subsequently rank. To find the valence electrons for Lewis structures, you count the sticks and dots it has, so let's do that first. Very simply, this molecule has 7 sticks and 4 dots. But does that mean that this molecule has 11 valence electrons? After all, 7 plus 4 is 11. Well, no, because a stick is 2 valence electrons and a dot is 1. So 7 sticks carry 14 valence electrons, and 4 dots mean 4. Add that together, and this molecule has 18 valence electrons. Okay, so we know for sure with this Lewis structure, but what about the chemical formulas? What exactly do we add and multiply together? Well, we're going to multiply the quantity and group number of an element, and do that for each element, and then add up all the products. CCl4 has 2 elements, carbon and chlorine, and for each we take into account how many there are in the group to which it belongs. We have 1 carbon and 4 chlorines as shown in the molecular formula, but how can we figure out the group number for each element? Well, that's where the periodic table comes in. Carbon's in group 4 and chlorine is in group 7. And that's because group number is synonymous with valence electron number. That means each individual carbon has 4 valence electrons and each chlorine atom has 7. Therefore, if one carbon has 4 valence electrons and this molecule has 1 carbon, this element contributes 1 times 4 valence electrons to this molecule. Chlorine, however, contributes 28 valence electrons because there are 7 valence electrons for each chlorine and there's 4 of them. Add it together and we get 32 valence electrons for the CCl4 molecule. And that means that C is an incorrect ranking because it's clear that molecule 2 has more valence electrons than molecule 1, but where does that molecule 3 fall within this ranking? Well, since we have its molecular formula, we can use the same equation as before, where we take into account the quantity and group number for each element in play. Here, we have carbon, hydrogen, and oxygen. The molecular formula tells us the quantity of each element. For example, there are 8 hydrogens in this molecule, and we've already established that carbon is in group 4. This means that we already know that carbon contributes 5 times 4 equals 20 valence electrons to the molecule. Let's find the group number of the other 2 elements. Hydrogen is in group 1, oxygen is in group 6. So 8 hydrogens contribute 8 valence electrons to the molecule. And each oxygen atom has 6, so 2 oxygens contribute 12 valence electrons to the molecule, which also means that we have 40 valence electrons total for C5H8O2. Now we have the valence electron count for all 3 molecules and can establish a ranking thereof. A is our correct answer, as 1 has the least valence electrons, then 2 and molecule 3 has the most with 40. To practice going from bond line structure to full completed Lewis structure, remember we didn't do that in this video, please check out the video on your screen.